Hey guys, so here's part 4 of the 5.2. We're going to be doing a word problem. So it says a 3D printer builds up layers of material to make three-dimensional models. Each deposited layer bonds to the layer below it. A company decides to make small display models of engine components using a 3D printer. Now the printer itself costs $24,000 and the material for each model costs $300. So we need to write an equation that gives the average cost per model as a function of the number of models. Now the first thing is we need to define our variables, meaning, figure out what variables we want to use and then say, what do they represent? Well, I think we use C to represent the cost, that would be, or the average cost, that would be probably easy there. And then we can use N to represent the number of models. Now, to write an equation here, it does tell us that we want to figure out the average cost. So let's think about, how do we figure out averages? Well, we take up everything that we have, we add it together, and divide it by how many things there are. Well, here, to do the cost, we're going to need to talk about the cost of the models and the cost of the printer. So we know for each model, the cost is $300. So like if we make one model, that's automatically $300. If we make two models, that's $600. If we make three models, that is $900, and so on. So we can represent that as 300N. Now we also have to include the cost of the printer. That is really a one-time cost, so that all they did was pay $24,000 for the printer, and that's it. Okay, so that basically is the cost, but remember we're doing the average. So how do we represent how many there are? Well, we divide by how many models there are, N, okay? So that'll be our model here. And actually this shouldn't be Y equals, it should be C equals. There we go. Make sure we use the correct variables there. Okay, now our next thing is we're going to graph the function and use the graph to estimate how many models must be printed for the average cost per model to fall to 700. Okay, so we're going to kind of do more of a sketch here. And we're going to talk about, because if you think about it, this is a rational function. So we're going to talk about our vertical and horizontal asymptotes and all that stuff. So let's first talk about how do we figure out the vertical asymptote. Well, we set what's in the denominator equal to 0. So that's going to be N equals 0, okay? And so that's our vertical, so it's going to have this. Now we do horizontal. Notice what form this is in. This is actually in our AX plus B over CX plus D form. So to find basically that horizontal asymptote, we take our A value, which is 300, and divide it by our C value, which is 1. So really, our horizontal asymptote, and I'm going to kind of just zoom here, let's say this is 300, okay? And really, we should be using the same variables as we used with C and N, but just kind of make sure. So we have that, and we set X equals 0, okay? So that means if we are trying to graph this, we're basically going to have something right here, okay? Now let's talk about how can we solve, because we still have to figure out using the graph to estimate how many models must be printed for the average cost. Now we actually could do this algebraically, and I'm going to show you how we can do this also with, graphically. So the 700, that's going to be our average cost. So that's 700 equals 300N plus 24,000 over N. Now we could just do this algebraically, meaning that I can multiply both sides by N. So I get 700N equals 300N. Okay? And then we solve, so I subtract 300N for both sides, so I get now 400. And I divide both sides by 400. So then when I divide that, I get 60. So basically N means 60, so 60 models, okay? But how can we do that graphically? Because there is a way to do it graphically. Okay. Well, to do this graphically, we're going to have to use our graphing calculator. Okay, so how we're going to do this is the 700 is actually going to represent one of our equations, and then the other function is going to represent a second. So the idea is that when we go into our graphing calculator, we're going to go to y equals. And what we're going to do here is actually, make sure I clear all this. There we go. So you'll notice we have like y1, y2, and so on. So what we can actually do is we can set the 700 to be, let's say, y1, and then the 300n plus 24,000 over n to be y2. So we plug that into our graphing calculator. And then here, so the thing is, when we use different variables, we can't really do that. We still have to use x and y. So here I will still have to use x. And actually, let me clear this, because since our numerator has multiple terms, I do got to use parentheses. So I have 300x, you got to use the x, that's right next to the apple key, plus 24,000. Yep. Then parentheses, and then we'll divide it by, and then we got to use x again. So we press graph, and we don't see anything, right? Well, this is where we do have to change our window. So if you actually go to window, we have this. So the idea is when we graph is that, you know, on the x-axis, we basically go from a negative 10 to positive 10, and that's the same on the y. We go from negative 10 to positive 10. So the negative 10 is actually our minimum for the x, and positive 10 is the max, because of course max means larger and min means smaller. Same thing with the y. Negative 10 is our min, and positive 10 is our max. So we actually have to change that window. So my minimum, I'm going to go ahead and make that a 0. And you can just put it in and then arrow down. I'm going to keep my max as a 10. Actually, I'll change that. I'll go to 100. Now you'll see XSCL, that means scale. So like, are we going to go by 1s, 2s, 3s? I'm going to go by 10s here. Okay, now for my y, I'm going to have 0. And then because we have 24,000, I'm going to go to 25,000, just go up a little bit. And then here, I'm going to go by, let's say, I don't think 10,000. We could go 5,000, maybe, yeah, we'll go by 5,000. Okay, now I'm going to go ahead and graph. There we go, and then we see where it's at, okay? So basically, we'll see where our graph lingers here, okay? So the idea is that these two are going to intersect. So we have that, and then we have this line, which is going to be the 700, okay? So that means the two lines intersect, and we can figure out where their intersection point is. And once we've done that, we should get 60 as our answer, because that's our x. So to do intersect, we're going to go to trace. Really, we're going to do second trace. So press the blue button and then trace. And then we're going to go to number 5, which says intersect. And so all you have to do is press enter 3 times. 1, 2, 3. And notice we do get an intersection of 60, 700, which that is correct. So 60 represents the number of models, and then we have the average cost of 700. So we basically did this correctly both algebraically and graphically. Okay, last thing we need to talk about is what happens to the average cost as more models are printed. Well, remember, we really can just use both our equation and our sketch that we have for our graph. Notice what our line is doing. We said y equals 300, that's our horizontal asymptote. So what's happening is our graph is going to get closer and closer and closer to that horizontal asymptote of 300. So as more models are being made, or as more models are being printed, notice that the average cost will actually just get very close to $300. So it'll approach 300. Because of that horizontal asymptote. Okay, make sure if you have any questions, you contact me, and make sure you work on that homework assignment. I'll see you guys later.